Okay, so here we're going to be talking about order of operations. When I talk about order of operations, I'm saying the order that I need to do a problem in when there's more than one operation. So addition, subtraction, multiplication, division, exponents, squaring something, cubing something, raising something to the fourth power, parentheses, square roots, absolute value, those are all operations. And we just have to do them in a certain order to preserve the natural order of operations. The way they interact is really important. Multiplication kind of trumps addition. It's really just repeated addition. So the way they interact needs to be preserved by the order that we perform them in. So I have this word problem on the right side that's basically showing you why we need a order of operations, why we need to perform them in a specific order. So you have 8 pieces of candy, and your friend says he has 4 more than double your piece of candy. So I'm just going to write that as an expression. So you have 8 pieces of candy. He has 4 more than that. So 8 plus 4. And it's 4 more than double your piece of candy. So we're just doubling your piece of candy. It's 2 times 8 plus 4. Okay, 2 times 8, 16, plus 4 would be 20. Translating that correctly is a big step. Actually, you might think we do 8 plus 4 times 2. You don't have to write this part down, all right? But you might have thought it was translating it that way, where you do the plus 4 first. That's not really what's happening. We're doubling your piece of candy, so it's just the 2 times 8. So 2 times 8 plus 4. Now let's say we did the 4 plus 8 first. Instead of doing multiplication first, let's say we did 4 plus 8, we get 12. 12 times 2 is not the same as 20. That's 24. That's not really what they're saying. They're saying it's double your piece of candy and then 4 more than that. Double your piece of candy and then 4 extra added on to that number, whatever that number is. The order is implied in that word problem, and it's implied in this multiplication and addition. We have to do that multiplication first. An easy way to remember this is using the acronym GEMDAS. You may have heard this as PEMDAS before. It's the exact same thing. Now we want to talk about more than just parentheses. So we have to add this G instead of P, where we're talking about grouping symbols. We're talking about any sort of grouping symbol. That's going to include square roots, absolute value, parentheses, and actually fractions sometimes are used as grouping symbols. So I'm going to just list those out here. So first off, we're talking about grouping, and I'm going to show different examples. We're talking about parentheses, brackets, which are basically just squared off parentheses, and they actually act exactly like parentheses. Those are different from absolute value bars, where they're just straight up and down lines. We'll get into that. But absolute value basically just changes whatever number you get inside of it into a positive. We'll see square roots. And again, you're going to do everything inside of there before you do the square root. And sometimes fraction bars act as a grouping symbol. Whenever you have something on top and something on the bottom, you're really going to do all the operations on top as a group, all the operations on bottom as a group, and then you can use that as division. The E stands for exponents. We're going to see a variety of kinds of exponents here. We're going to see something squared, something cubed, and this year especially, you should have seen this maybe a little bit last year, but this year especially, we're going to talk about negative exponents. So negative 2 as an exponent. It doesn't just change the answer into a negative. Actually, it kind of changes it into a fraction or a decimal. Then we have multiplication and division. And the reason those two are together is because we need to go from left to right there. You always work from left to right when you have either multiplication or division. When you're trying to decide between those two, you have to go left to right. Basically, you just do the one on the left first. One thing I also want to point out, multiplication sometimes is parentheses. It's not the same as the parentheses I'm talking about there. The grouping symbol, I'm saying you have to do everything inside of there. Sometimes we'll see something like this, where it really just means multiplication. It's not acting as parentheses. We've already done everything inside the parentheses there. That's what the grouping symbol really means. This is just multiplication. And the final two are adding and subtracting. Again, those are in the same box because we're talking about those together. Adding and subtracting are on the same level. You have to perform those from left to right. Okay, so you always want to use GEMDAS, and actually it might be helpful to write it down the side of your paper. And just kind of use it as a checklist. I'm putting the M and the D next to each other, and the A and the S next to each other, just to make sure that I'm doing those from left to right. Whatever I see first, really, if I have to decide between multiplication and division, I just work left to right. Same thing with addition and subtraction. So here, I see I don't have any grouping symbols. I don't have parentheses, brackets, square root, absolute value. So I'm just going to do my exponents first. My grouping symbol is already taken care of. I do have an exponent. So I'm going to do this exponent first. 4 squared is 16. I didn't change anything else. The only thing I actually changed was that exponent. Really, GEMDAS is just about being meticulous and writing out all of your steps. All right, so now I see I have subtraction, I have addition, I have division, and I have multiplication. I know it's not addition or subtraction, those are going to happen last. I have division and multiplication. I'm trying to decide between the two of them. I'm going from left to right, so I'm actually going to do this division next. So I have 16 minus 8 plus 9 divided by 3 turns into a 3 times 6. Now I can do that multiplication. I have subtraction, I have addition, I have multiplication. Multiplication has to happen next. So now I do 16 minus 8 plus, just that part changes, 3 times 6 is 18. Now I have subtraction and addition. I have to work that left to right. Before you add, you have to do the subtraction. You're going left to right. That subtraction before that addition, that would give me 8 plus 18. And 8 plus 18 gives me a final answer of 26. It really is just about being meticulous and working through GEMDAS in the correct order, taking your time, showing all of your steps, and just being careful. On the second one, I do actually have a grouping symbol. I have these parentheses, so I'm going to do everything inside of there first. That means I'm doing -8 plus 6. If there was more than one operation inside of there, I'd also have to follow order of operations in there. So right now I'm just doing that -8 plus 6. That would give me -2 divided by 10. So I still want to follow order of operations. Now I'm going to do, I took care of my grouping symbol. I don't have any exponents. I have multiplication and division. My multiplication is first. I'm just reading that straight across, just like a sentence. That multiplication has to happen first. So I'm going to do -25 times a -2. You really have to get used to seeing that minus sign or the subtraction sign in front of the number. That -25 as attached to that 25. It's -25. I'm doing -25 times a -2. That's a positive 50. And that's how I'm going to write it in the next step. I'm going to write it as a positive 50 or a plus 50. This was subtraction. And now it changed into a positive number after I use that. It's a subtraction or a negative sign. Those are the same exact thing here. Subtracting that 25 and then multiplying it times -2, and a -25 times a -2 are the exact same thing. I multiply those and I get a positive number. It can't change into multiplication. That's the real common mistake there. It doesn't change into multiplication, it changes into an addition sign because it's now a positive number from that multiplication. It was subtraction, it changed into a positive. That changes really into a plus sign because the operation really doesn't change. It's basically like we did it like this. You don't have to write this part, but I just want to show you how we could do that in two separate steps. If we kept that as subtraction, and we forgot about it being attached to that 25, you can do that, but then it's just going to take you an extra step. You would do 25 times negative 2. That would give you a negative 50. And now you see a minus a negative, which is the same thing as just adding a positive version of that number. So instead of doing that, I'm going to include the negative sign in the multiplication, show it as negative 25 and negative 2 being multiplied to change that into a positive 50 right away. I'm going to keep the dividing by 10 at the end of that, because that's important. I can't do that addition yet. I have to do the division first. I'm dividing 50 by 10. 50 divided by 10 is just 5. And then 50 plus 5 gives me an answer of 55. And the next one I see, I do have a grouping symbol, but everything inside of there is actually simplified already. There's nothing to actually do inside the grouping symbol, inside the parentheses here. I actually have another grouping symbol. This fraction bar acts as a grouping symbol. I want to do everything on top and everything on the bottom, and then I can use the fraction bar as a division. I'm going to divide whatever I get from the top by whatever I get from the bottom. So I have to follow order of operations on top. I'm going to do the multiplication first. 12, it says a positive 4 is being multiplied times a negative 5. A 4 times a negative 5, positive 4 times negative 5 gives me a negative 20. And that's exactly what I'm going to write. I'm going to write that as a minus 20. 4 times negative 5 is negative 20. Just like the last problem, this addition, it can't just change into like 12 times negative 20. It's not changing into multiplication. It was addition. That adding is really changing into a subtraction symbol. We're now combining a 12 and a negative 20, or 12 minus 20. Those are actually the same thing. So I'm going to do that on top, and I'm going to do the subtraction on the bottom. That's going to give me negative 8 on top, divided by negative 2 on the bottom. Negative divided by negative gives me a positive. Negative 8 divided by negative 2 is a positive 4. Now we're going to do in the parentheses first. Again, use this as a checklist as you go. I'm going to do in the grouping symbol first. So I'm doing in the parentheses, and I have to follow order of operations inside of there. So before I do that subtraction, before I subtract these two numbers, I have to do my exponent. So that's going to be 2 squared. So I'm going to have it as negative 10 minus 12 divided by 2 times 8 minus what changed into a 4. It's just 2 times 2, or 2 squared. An exponent is telling us how many times we're multiplying that number by itself. So I'm taking 2 and multiplying it by itself 2 times. When I finish inside the parentheses before I do anything else, negative 10 minus 12 divided by 2 times 8 minus 4 is just 4. And now I have subtraction, I have division, and I have multiplication. So subtraction has to come last. So I'm trying to decide between division and multiplication. This is when I have to work left to right. I have to do negative 12 divided by 2. So that changes into a negative 6 times 4. The multiplication part of that didn't change. Just changes the number in front of the parentheses now. Just divided negative 12 by 2. That gave me a negative 6. Now I can do the multiplication. I have a subtraction sign, and I have multiplication. So it's negative 10 minus 24. I really am thinking about this as multiplying a negative 6 times whatever's in the parentheses. Negative 6 times positive 4 gives me a negative 24, or minus 24. Those are the same thing. Negative 10 minus 24 is negative 34.